Enough delays. Advent of Code 2023, day 14, is called Parabolic Reflector Dish. You reach the place where all the mirrors were pointing. There's some mirrors from yesterday. A massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in a slightly wrong direction. If the dish is meant to focus light, all it's doing right now is sending it into a vague direction. The system must be what provides energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Okay. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. The rounded rocks will roll when the platform is tilted, while the cube-shaped rocks will stay in place. You note the positions of all the empty spaces and rocks. Your puzzle input. Okay. For example, all right, so we have round rocks and we have cube rocks. I guess they should be round and square or cube and sphere. They've been getting a little picky. Start by tilting the lever so all the rocks will slide north as far as they will go. Oh, I see. Okay, so we just have to move everything north. You notice that the support beams along the side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load is caused by a single rounded rock. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load. Oh, that's convenient. So the amount of load caused by each rock in each row. Oh, I see. So we just subtract the height. Okay. Or height minus the row it's on. Got it. The total load is the sum of the load caused by all the rounded rocks. In this example, we got 136. All right. This seems a straightforward puzzle for part 1. Get input 2023 14. So we've got 100 lines. And I think my window is 100 wide, so it looks like it might be 100 by 100. But it looks like your typical thing. So let's just dig in. Make that 14. Make this 14. 14, 14, and then finally day 14. Okay. '23, 14. Good. All right, I think we're up and running. Parsing is straightforward, I think. We can do is create a platform type. Well, maybe we don't need a platform because all we need is a hash map, and then we can save the rows and the columns, right? So we can say platform is a hash map from a row col to a rock. And then we can have width and height, right? Enum rock, it's going to be rounded and cube, right? Cube-shaped and rounded. They don't say rounded shape. Maybe say cube-shaped. No, this is good. We do need to import hash map. And then we just need to parse all the lines. Let lines equals lib read lines. Input 2023 14.text for row line in lines iter enumerate for col ch in line chars enumerate. How many times have I done that this advent of code? We're going to match on the character. If it is a dot, we do nothing. If it is a capital O, we're going to insert. Knox says, I've been watching all the VODs, but I finally can catch a stream live. Oh, welcome. I think I only have up to 11. Yeah, up to 11 on YouTube. I haven't finished 12 yet, and I started editing 13 last night, and I just never finished it. So VODs are the way to go. You learner, welcome. Scoop says, good morning. Good morning. Good to see you. Let's see, self-platform, insert, row as I64, call as I64, rock, rounded. I'm gonna call it rock? Yeah, it's right there. Why won't it let me do that? Norpix, welcome. Thank you for the follow. And this just inserts a cube. Yeah, I don't know why it's not. Oh, there it goes. I just needed to finish this. Okay, so this should give us all the rocks. Now we can implement. Oh, right. I wanted to do width and height. Self width is equal to line 0 len, and self height is lines of len. Right? All right, let's fix this. This is a bug in my code. Panic. Unexpected character. CH. That should cover that. And now I guess what we can do is create a little function to calculate the total load. And then we'll write a little function to do a tilt north. I imagine that part 2 is going to have us tilt the other three cardinal directions, but I don't want to get ahead of myself. Maybe it's like get all the rocks to the upper left-hand corner or something. Write a solver for that. Load. So we just need that, and it'll return an I64. So this will be self-platform keys. Right, we only care about the rows. Yeah, so we can get the keys, and we can map every key. K dot 0 is going to be the row, and we want to say self height minus the row that we're on. Right, so if we have 10 rows, 0 through 9, we're on row 0, we say 10 minus 0, we get 9, and so on and so on. And then there's just this sum, 64. That should do that one, right? Load is never used. Let's fix that. Self-load. All right, so we know what the load is before we tilt it to the north. 183, 288. Scoop says only for rounded rocks. Oh, excellent point. Thank you. That complicates things. Filter map. And we don't want keys then. We just want to do iter. Key value. If v is equal to rock rounded, then it's going to be sum of this. Else, it's going to be none, right? Bleh. No, it looks ugly, but it probably works. Oh, right. Let's add a bunch of stuff here. Copy, clone, and partial EQ. And then I have to deref it. All right. So our new load is 99,918. Thank you, Scoops. All right. So now we just need to tilt to the north. Tilting north is straightforward because you can just go row by row and make a new platform. So we can say let platform equals hash map new, and we can say for row in 0 dot dot self height, for call in 0 dot dot self width, match self, wait, what do I call it here? Platform, self platform. I guess I'm confusing myself because this was also called platform. Platform get row call. And can we do the match arms? Will it fill in the interiors? It did not fill in the interiors. So if it's none, we don't do anything. If it's some, let's do the easy case first. No, rock. Cube. All we have to do is put it into the new one. Platform insert. Actually, we don't. Oh, we do care. I was about to say we don't care about the location of the things, but if we're generating a new platform, I imagine it's going to be useful for part 2. We'll do row call rock cube. Mohad, hello. And then we have some, and this is the interesting case, rounded. We have to actually move. So we can say let mut y equals row, and then we just want to shift y up until we hit something. Oh, yeah. So we can say while y is greater than 0 and the new platform does not contain anything, contains key, row call. Then we can say y minus 1. I'm going to write a dumper because I'm going to dump out the thing because it looks like we have a before and after here. So I want to be able to confirm I did it right. So we just keep shifting up until we hit either the top edge or we hit something that's already there, right? Because we're going from 0 down. We're working our way down, so anything above us is going to be there in the new platform. And now we can just say platform insert y call rock rounded. There. And then we just print out the load. That didn't work because max arms have incompatible types. Obviously. All right. It still says 99918 because I did self load. Oh. If I want to have this neat. Ron Brogzov, welcome to the channel. Thank you for the follow. I imagine this is going to be useful for part 2. So I'm going to, instead of doing it this way, we're going to make a platform. Struct platform. And we'll call this rocks rather than duplicating the platform thing here. Rocks. And now we have to change our parser because we no longer have this. We have self platform width and self platform height and self platform rocks insert. That's a little awkward. Trait. Oh, I have to derive default. I'll probably want to also clone it. Rocks. Oops. Like that. Self platform height. Platform. We'll get there. Rocks get. Yeah. Everything else is good. And then we're going to move the load code down here. Like that. And this will just be impl platform. And this will just be self rocks like this. Like that. Right? And now I can say, instead of self load, I can say platform default platform width equals self width. I should have a platform cloner. So we can do it that way, and then I can just say platform load here. Which means I have to put the rocks and rocks and rocks. All right. That can't be right. That's too round of a number for it to be correct. All right, so like I promised, I'm going to write a little dump function for row in dot height, for call in 0 dot width, and we'll just do it before and after, and we can print it out. I mean, I would be in shock if that were right. No, we can do the same thing. Match self rocks get row call. If it's none, we can print out a dot. Right, like that. Scoop says, you know the next question, right? What does the sample data do? Yeah, I'm getting there. I'm going to write this little dumper program, and then I'm going to switch over to the test input. Rocks rounded is a capital O, and some rock cube is a hash. That should do it, right? I think I'm a little off in terms of my formatting here, but I missed that. That's why. There we go. Okay, so we're going to read the test input, which I haven't copied over yet. Self dot and self dot. There we go. Oh, now part 1 is 0. Why would that have changed? Oh, because I didn't read anything in it. Oh, no. Oh, because I'm reading some old test input. There we go. Let's delete that. Okay, so we'll grab this. Like that. Hit run. 90. All right, and it was supposed to be 130 something, right? 136. Okay. So now we print out the before and after. So we're going to say self platform dump. And we can see where we messed up. B4. And oh. No, this goes in part 1 here. Then we're going to do this. And then we're going to say println after self platform dump. No, platform dump. Like that. All right. Oh, they all fell. They all fell because platform rocks doesn't contain the key that I was expecting it to contain. Yeah, they all ended up on the top. Okay, so let's see what's going wrong here. I'm grabbing the data from platform rocks. If we hit a cube, we're going to insert it in there. So it should contain a key for it. If we hit a rounded rock, then we're going to start at the current row. Oh, I see. I see what I did wrong. This should be y minus 1. There we go. And now we got 136. Yeah, Scoops, you saw it same time I did. Okay, good. All right, so now we can tilt north. Let's try our... So that's why it was 10,000, because all the rocks were at the front, at the top of the platform, the north end of the platform. Oop. Okay, we got 107, 142. Does that sound good? That sounds less round. Hey, that's the right answer. Okay, record time. All right, before I continue to part 2, is there anything I want to do here? Oh yeah, I want to take out this code. You don't need that or that. There we go. Git status, git add source git commit -m 2023 day 14 part 1 done in the bag. Scoop says party time. All right. Oh. 14. Continue to part 2. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After one cycle, the platform will have finished rolling the rounded rocks in these 4 directions in that order. Okay, so we do a full cycle. We have output for 3 of the cycles, so we can at least debug our code. This process should work if you leave it running long enough, but you're still worried about the north support beams. To make sure they'll survive for a while, you need to calculate the total load on the north support beams after, what is this? A gajillion cycles, whatever that is. In the above example, after that many cycles, the total load on the north support beams is 64. Run the spin cycle for that many cycles after, what is the total load? All right, so what this is going to, I'm already suspecting one of 2 things is going to be true. One possibility is that we do enough spin cycles and it reaches stasis. In other words, you do a cycle and it just returns to the same exact location or the same exact state. The other possibility is that there's a loop, right? There's like a run up and then at some point we get to where we go through a bunch and then we come back to the midpoint and then we just have this loop that goes like that. So those are the 2 possibilities, because I'm not going to run it however many times this is. What is this? This is 1 billion. I'm not going to run it 1 billion times. That will take all day. So that's my working assumption right now, that either it reaches a static state or it has some computable loop. So let's work on that assumption. What I'm going to do first then is extract the tilt code into a tilter function. So we're going to do that first. So I can run tilts in different directions. Fn tilt self direction, which I need to invent. And it's going to generate a new platform with the rocks having been tilted in that direction. Let's create a direction. And it was, what were the directions? I just want to do it in the same order. Not that it matters, it's just nice to be consistent. North, west, south, east. Okay. Now this just tilts north, but we can make it general. When you're tilting north, it's okay to go in this order. I'm gonna have to change all of this stuff here. Let new platform equals platform default. I should pull that out here. That's where it was. Okay. And then we're going to just return the platform, having been tilted in the direction specified. Right, so as I was saying, so north it's okay, but if we're going to tilt it south, we actually have to start this side and move everything down. So this row first and then this row. The thing is, the columns don't matter when you're tilting it north or south. You can do it in any column order you want. And then an east-west is going to have the opposite thing. So going west, you can go from the beginning to the end. But going east, you have to go from the end to the beginning. Okay. So that means these things need to change depending on what direction we're going. And we also want to change this stuff here. All right. How are we going to do this? Let rows calls delta row and delta column equals match direction. If we're going north, the rows are just going to be 0 dot dot self height, and the columns will be 0 dot dot self width, right? Delta row is going to be -1 and delta column will be 0. Okay, so that's the way we're going to do it. And then through here, we'll say rows and cols. And then we're going to change, instead of y, we're going to use r. Let mut c equals col, right? And then instead of y -1, this will be row plus dr, and this will be c plus dc. And we're going to have to make a bigger while thing here. This will be while row is greater than 0 and col is greater than 0 and row is less than self height and col is less than self height, and platform does not contain this. Oh, yeah, that might be okay. R plus equals dr and c plus equals dc, and then we're going to insert into row and column the rounded rock. And now we don't want to, oh, right, we don't have this anymore. Okay, so we can make this go away, and what we can do is say let north tilted platform is equal to self platform tilt direction north. That was the only match arm I filled in, so hopefully that's going to work. North tilted platform load. Move occurs. What are we moving? Oh, we have to, okay, because we're going to run this. Wait a minute. This is a range, right? Can I just do this then? Known method name iter. How can I loop over the calls multiple times? Right, because every time through the loop, it's going to need a range, and I don't want to have to duplicate it. There's an implicit call to into iter. Does into iter exist on range? But into range, into iter. I can just clone it. Okay. That's a little bit wasteful. And I broke it. That's the wrong number. So it should be 107.142. I'm probably missing out on an edge condition here. R plus dr, and maybe c plus dc, and c plus dc. No, that's even worse. Oh, we do want to hit equal to 0. Okay. There we go. Okay. Debugged. Oh, Scoops, I missed your comment. Yeah, calls clone works, but that's kind of annoying. So now let's do the other easy direction. Tilting it north means we can go in row order. Tilting it to the east, right? This side is east. If we shift everything to the right, we can do it in column order. So we can use the same, let's delete that, yank that, paste that. We can use the same directions here, except we want to add one to each of the columns. Oh, no, I'm sorry, I have it backwards. To go west, we can do it in the same order. Like that. And we're going to subtract 1. Minus. Scoop says, I think it's only cloning 2 use sizes. Yeah, that's true. That's true. The start and end, because the range has a start and end in its struct, and they're both pub. So technically what I could do is I could say calls start, calls end, and that would avoid the cloning, right? Rows start, rows end. But going back, oh yeah, so south, we can't do this. Watch, this is what I wanted to do, and I just realized I can't do it. Self, height, reverse, comma, this. We can't do this because this is a reverse type now, unfortunately. So it's a different type. So now the match arms have different, yeah, match arms have incompatible types. Dang it. All right. Well, here's what I'm going to do. I'm going to cheat. Scoop says I tried to got incompatible types. Yeah, I'm going to cheat. Let down is equal to 0 dot dot self height. Iter collect vec. And this should be a vector of something. Oh, it isn't. Why not? You can't iter that? Can you collect that? Okay. And now down should be a vec of, okay. And now we can go up and put a rev in there. It just means duplicating this every time we do this tilt. So if we're going to go to the right, it's going to be 0 dot dot self width collect back, right? And then left is rev, right? If we're going to shift everything to the left, oh no, that's backwards. Ooh, I almost got that wrong. If we're shifting things to the right, we want to start at the end and work our way backwards. If we're shifting things to the left, we want to start at the left and work our way forwards. Okay, so now these become, north goes down, and it doesn't matter which direction we go here. West doesn't matter which direction we go here, so we can choose down. And if we're going west, we want to go left. Then this becomes up, and this doesn't matter, right? And then east, it doesn't matter if we go up or down, and go left. And I chose up just to be symmetric here. So down right, down left, up right, up left. All right. And that didn't work because, oh, now we actually have to do it, right? We have to do rows this way because it's a vector. But that's going to make everything a reference, isn't it? Right, now row is a reference to a use. Is that all of them? All right. This still says 107.142. So I think we did it right. Let's do, so in part 2 now. Oh, well, how about this? Let's commit these, this because it's a big refactor. I'm going to disable this thing here. Allow dead code. I don't know if the allow needs to be before or after. All right, git status, git commit -am refactor part 1 to prepare for part 2. Okay. Now we can do a cycle, right? We can say let mut tiltify equals self platform clone, right? And now we'll go through the sequence for dir in dirs, and I'm going to make that down here, const dirs direction for equals these 4 directions. It's 3 better than 1 direction. North, west, south, east. Got to get the order correct, right? For dir and dirs, we're going to say tilt in that direction. Tiltify equals tiltify dot tilt dir. And then I'm going to dump it. Tiltify dump. And we can see, oop. Don't I press? Oh, okay. Ah. Copy clone, partial equal. I should have like a little macro that does that. Oops. Okay, well, I think it failed because everything shifted over here. So we got to fix that. But I wanted to use the test input. So let's figure out what went wrong. Let's print out each tilt so I can see if it looks right and we can see which one went wrong. Yeah, println tilting dir tiltify dump. And this actually, we can actually put in here, right? Tiltify load. All right, so tilting north, we actually had that already done, right? Because that's already for part 1, so that's correct. Now tilting west. That seems to be correct. That looks right. Okay, tilting south. Oh, okay, so it's just tilting east is messed up. Okay, so let's fix that. Because up and left were used for south and west. If we're tilting to the right. Oh, wait a minute. This should be right. Oh, it's this one that doesn't matter. Okay. All right, so this might be better. Let's see. Yes. Okay, good. Good. So now we should be able to tilt it multiple cycles, right? So let's just cycle it 3 times in 0.3. Yeah? And we can print out each cycle. Oops. Println cycle, I forgot to give it a name. Okay, so after 1 cycle, it looks like that. We already verified that. After 2 cycles, it looks like this. Good. And after 3 cycles, it looks very similar, but different. Okay. I think we have the tilting. Now we have to figure out how to detect the cycles. And I think it's just a matter of mapping or hashing on the location of the rocks, which are all the keys, and waiting for a duplicate. Let mut cycle detection. Well, let's call it loop detection so that it doesn't conflict with this cycle term here. Hash map new, And what we'll do is we'll grab all the keys. The problem is when you say tiltify keys, it's not giving me that. It's not telling me what keys is. Oh, because it's a platform. Platform keys. Rocks. We'll get there. We'll get there. This is an iterator visiting all the keys in an arbitrary order. Nice law. Good morning. And that means we can't rely on the keys, the order we get the keys in, which means we have to sort them. Right? Before we put them in the hash map. Oh, that's a reference to all those things. Okay, this is going to take up a lot of memory, but that's what we're made out of. Nice Law says B-tree map maintains a key order, right? Oh, okay, let's try that. I always go to vec, but B-tree map set, right? Oh, let's import that. Because we just need the set. Yeah, okay. Hopefully it'll hash to the same value. We'll find out. Because we need to stick it in our loop detector. So loop detector dot insert keyvec 0. This is how many loops we've got, how many cycles we've gone through. That's what that 0 is for. So we go through the cycles, and now we do this thing here. Right? And we can say if oh, that's one thing. So let me find out. I think insert will not do the insert. The map did not have the key present. None is returned. If the map did have the key present, the value is updated. Okay, I don't want the value to update. Oops. So instead, what we're going to do, we're going to say if loop detector contains keyvec, then we found a loop. Oh no, we can say if let some val equals get. Then we can say println loop detected from val to I, and we're going to start off I 0. This is going to be a loop, and this is going to be let start end equals loop I, else we're going to insert it. Loop detector insert keyvec I, and I have to increment I. And I expected a semicolon. Scoop says, but the old value is returned, so you know where the cycle happened. Oh, that would simplify the code a little bit. Value is updated and the old value is returned. See, I didn't finish reading the sentence. I stopped partway through the sentence. That's bad. Okay, so that would be easier. If let some blah, 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 insert keyvec I, break val I. Right. That simplifies things a little bit. And this is not going to be the right answer, but we'll see. We'll see what the loop looks like. Just make sure I don't have any more calls to dump. Good. Loop detected from 3 to 10. Oh yeah, we're still on the other test input. But we have a 3 to 10. We got a nice number for part 2, but it's supposed to be 64. So that's where the fiddling around comes into play. So we have a start and end. Let mod. Oh, I can't use mod. Difference is equal to end minus start. Let remaining loops is equal to, I think this is 1 billion, but I'm going to copy paste it just to be on the safe side, minus diff. Oh, no. Minus start. And then we have let phase. I don't know what to call this. Robooz, thank you for the follow. Loop says, I didn't know you could return values from loop like that. Neat. Yeah, you can't do that for fors or whiles, but you can do, if you just stick a loop on there, then you can just return a value and get it right out of there. It's pretty nice. The phase we're on then is the remaining loops mod the diff. That's why I wanted to call it mod, but you can't call it mod in Rust. And then we just need to do phase more cycles. Right? For something in 0 dot dot phase. You know what I could probably do is store the score for each one inside this hash map. Instead of just the number, we can also store the score. But then I'd be computing a score every time, and I can just do it this way. This is simple enough. Let's do that. And then their answer is still defy load. It doesn't build because for some reason I decided to call that. 64. Answer detected. All right, let's use the real input, as one does. Uh-oh, it's a long loop. 104,815. I'm curious what the loop was. I'm going to run it again. Yay! That's the right answer. Huzzah! I want to see what the loop was. Val.i. How long is this thing? In thousands? Oh, no, that's not bad. That's not bad at all. Okay. It still takes a long time. It takes 5 seconds to compute. That's what I was thinking. Oh, it must be in the thousands somewhere. But my code is apparently was wicked slow. Scoops, let's take a look at your answer. Now, let me get this stuff committed first, and then we'll do that. Let me get rid of that print I just stuck in there. And I think this is good. Let's Clippy. Field assignment outside of initializer for instance created with default. Yes, I agree. FN prep self platform. Let mut plat equals platform default. Platform rocks hash set new hash map new width self width height self height. Watch, this is going to break it. 116. Where did I do it? Oh, down here. Yeah. Platform equals platform self platform. Oh, self prep. There. Is that better? I'm going to run it again. It could take another 5 seconds to make sure I didn't break it. 104,815. Yeah, that sounds right. Okay. And now Clippy's happy. Get rid of this line. All right, I think we're good.